So the final piece we're going to discuss today in terms of power is, Ness always talks about the practicality of the effects I'm looking for, right? We only need to be practical. We need to have a sense of how big a difference we're looking for, and then that allows us, to make sure we have a large enough sample size to give us the best chance of rejecting the null and ensuring that we have decent statistical power. At the opposite end of the spectrum is big data and statistical power. And in that case, we have a wealth in terms of we have a large number of participants because we're pulling data out from, let's say, operational data sets or databases that are used by, say, large corporations such as financial institutions. And what does that mean when we have a super large N? So let's look at an example. So Scotiabank is a proud supporter of hockey in Canada. It helps fund minor hockey, and it also is a sponsor of the Toronto Maple Leafs professional hockey team. And it also, so as you can see in the photograph, the Scotiabank logo is plastered on the side of Toronto Maple Leafs hockey players' helmets. Right? It's sponsorship. So let's go into big data, and we get some big data analytics going, and we have access to the Scotiabank database, and they have one question in there. They ask who's a hockey fan and who isn't, and then they look at your. They're looking at for their investment clients. So those who have a self-administered trading account where they trade themselves on the stock markets, right? So they have a trading account, and we're looking at the average number of trades per month. And they pull up from their data. They have the average number of trades per month from a not a hockey fan, don't like hockey, and from a hockey fan, right? So, and they look at it and they want to compare. We're sponsoring hockey. Are people who like hockey, are they worth the investment in terms of sponsorship and advertising? Do we want to have as Scotiabank customers those who like hockey, who were drawn to us from our promotion and sponsorship of hockey? So our advertising that's streamed through hockey. And we can see here that for a not a hockey fan, I want to see, is there a statistically significant difference between the average number of trades for a hockey fan compared to a not a hockey fan? And I'll do it as a two-tailed test. And I want to see, though, hopefully a hockey fan is someone who, trades cost money, so like $10 a trade. If I want hockey fans should probably spend more money on banking than non-hockey fans. It's a kind of a goofy example. So a standard deviation of 5, and a mean of 23.2 for not a hockey fan, and a mean of 23.26. So the hockey fans seem to perform more trades and therefore bring more revenue to Scotiabank because they have more trades. And I have, from their huge big data set, I have 60,000 non-hockey fans and 60,000 hockey fans. And I run my t-test, independent means t-test, and I get a t-observed of negative 2.078, and t-critical is negative 1.96. I reject the null hypothesis. Hockey fans perform more stock trades on a monthly basis than non-hockey fans. Scotiabank, you're doing a good job by sponsoring hockey and advertising through hockey. Because through your advertising through hockey, you're drawing in those hockey fans, and they generate a lot of revenue through stock trade costs. Right, if $10 a trade, and they're having more trades than the non-hockey fan. Wow. Right, that's like blindly doing this. But the problem here is, once again, we got to look at what are we looking at here. Are we looking at something that is statistically significant, but isn't practically significant? So I'm getting a significant effect because of my supersized n, because our standard error is variance for group 1 divided by the n of variance for group 1 divided by the n for group 1 plus the variance for group 2 divided by the n for group 2, take the square root of that. Right? I'm detecting a difference of 6 cents. Or 0.06 trades, not 6 cents, 0.06 trades. It's statistically significant, but is it of any practical importance? Well, let's see. Okay, So I look from the Scotia. I'm not a client of Scotia. I'm actually a TD client. Let's look at the average. Let's say 100, less than 150 trades a quarter. Trade cost is $10. So every trade someone executes in terms of buying or selling a stock costs $10. Okay. The difference in number of trades between the two groups is 0.06 of a trade. That is statistically significant, but really, it's of no practical value. What does that represent? If each trade costs $10 and the cost per trade difference is basically 6 cents, basically, right? So my difference is so my difference is 0.06, 9 times by 0.06, which is zero point 0.6. I take that 0.6, where I'm looking at a difference of 60 cents, 0.06, multiplied by the $10, and then multiplied by 60,000 means that I'm looking at basically roughly around $36,000 in net revenue for this study for 60,000 people. That isn't, and considering that they're spending $40 million per year to slap their name on the arena, that isn't really that big a difference, right? It's statistically significant, but not practically significant. Okay, and that is it. So when you're working with big data, you have to be careful in terms of not just blindly following your statistical inferential tests. You got to also step back and go, okay, I found a statistical difference. My ends are huge. Is this of any practical value?